Exposure compensation is a technique for adjusting the exposure indicated by a photographic exposure meter, in consideration of factors that may cause the indicated exposure to result in a less than optimal image. Factors considered may include unusual lighting distribution, variations within a camera system, filters, non-standard processing, or intended underexposure or overexposure. Cinematographers may also apply exposure compensation for changes in shutter angle or film speed, among other factors. Most DSLR cameras have a display whereby the photographer can set the camera to either over or underexpose the subject by up to 3 f-stops in January 3rd stop intervals. Each number on the scale represents 1 f-stop, decreasing the exposure by 1 f-stop will halve the amount of light reaching the sensor. The dots in between the numbers represent January 3rd of an f-stop. Exposure compensation on still cameras. In photography, some cameras include exposure compensation as a feature to allow the user to adjust the automatically calculated exposure. Compensation can be either positive or negative, and is frequently available in third or half-step, less commonly in full steps or even quarter-step increments, usually up to 2 or 3 steps in either direction. A few film and some digital cameras allow a greater range of up to 4, 5 or even 6 steps in both directions. Camera exposure compensation is commonly stated in terms of EV units. 1 EV is equal to 1 exposure step, corresponding to a doubling of exposure. Exposure can be adjusted by changing either the lens f number or the exposure time. Which one is changed usually depends on the camera's exposure mode. If the mode is aperture priority, exposure compensation changes the exposure time. If the mode is shutter priority, the f number is changed. If a flash is being used, some cameras will adjust it as well. Adjustment for lighting distribution. The earliest reflected light exposure meters were wide-angle, averaging types, measuring the average scene luminance. Exposure meter calibration was chosen to result in the A-O exposures for typical outdoor scenes. When measuring a single scene element, the indicated exposure is in the approximate middle of the film or electronic sensor's exposure range. When measuring a scene with a typical distribution of light and dark elements, or a single element that is lighter or darker than a middle tone, the indicated exposure may not be optimal. For example, a scene with predominantly light tones often will be underexposed, while a scene with predominantly dark tones often will be overexposed. That both scenes require the same exposure, regardless of the meter indication, becomes obvious from a scene that includes both a white horse and a black horse. A photographer usually can recognize the difference between a white horse and a black horse. A meter usually cannot. When metering a white horse, a photographer can apply exposure compensation so that the white horse is rendered as white. Many modern cameras incorporate metering systems that measure scene contrast as well as average luminance, and employ sophisticated algorithms to infer the appropriate exposure from these data. In scenes with very unusual lighting, however, these metering systems sometimes cannot match the judgment of a skilled photographer, so exposure compensation still may be needed. Exposure compensation using the zone system. An early application of exposure compensation was the zone system developed by Ansel Adams and Fred Archer. Although the zone system has sometimes been regarded as complex, the basic concept is quite simple: render dark objects as dark and light objects as light, according to the photographer's visualization. Developed for black and white film, the zone system divided luminance into 11 zones, with Zone 0 representing pure black and Zone X representing pure white. The meter indication would place whatever was metered on Zone V, a medium gray. The tonal range of color negative film is slightly less than that of black and white film, and the tonal range of color reversal film and digital sensors even less. Accordingly, there are fewer zones between pure black and pure white. The meter indication, however, remains Zone V. The relationship between exposure compensation and exposure zones is straightforward. An exposure compensation of 1 EV is equal to a change of 1 zone. Thus exposure compensation of a 1 EV is equivalent to placement on Zone 4, and exposure compensation of +2 EV is equivalent to placement on Zone 7. The zone system is a very specialized form of exposure compensation, and is used most effectively when metering individual scene elements, such as a sunlit rock or the bark of a tree and shade. Many cameras incorporate narrow-angle spot meters to facilitate such measurements. Because of the limited tonal range, an exposure compensation range of A plus or minus 2 eV is often sufficient for using the zone system with color film and digital sensors. See also, exposure value, exposure index, light meter, zone system, exposure bracketing, auto exposure bracketing. Notes: ABC by default, the Minolta 7000 and 9000 support exposure compensation in half-step increments over a range of A plus or minus 4.0 eV, however, in conjunction with the Minolta program back Super 70/90 or the 100 exposure back EB90 quarter steps are supported over an effective range of A plus or minus 6.0 eV. In order to cope with a finer granularity, aperture and shutter speed settings are displayed in a proprietary suffix notation, that is, a full f-stop of 2.8 is displayed as 2.80, the next quarter steps would be 2.81, 2.82, 2.83, before it would continue with 4.00, etc. Photographers commonly refer to exposure changes in terms of stops, but properly, an aperture stop is a device that regulates the amount of light, while a step is a division of a scale. The standard exposure scale consists of power of 2 steps. A one-step exposure increase doubles the exposure, while a one-step decrease halves the exposure. These steps are what are commonly referred to as stops. The Nikon F5 and F6 support an exposure compensation range of A plus or minus 5.0 eV. With firmware 2.0, the Sony Alpha DSLR A850 and DSLR A900 support an extended exposure compensation range of A plus or minus 5.0 eV. Zones refer to exposure. Adams distinguishes among exposure zones, negative density values, and print values. The negative density value is controlled by exposure and a negative development. The print value is controlled by the negative density value, and the paper exposure and development. References: Exposure Compensation by Jeff Lawrence, Van der Walt, ed. OEISO and Film Speed Euro. Under Basic Photography. IllustratedPhotography.com. Retrieved July 7, 2011. Adams, Ansel. The Negative. Boston, New York Graphics Society. ISBN 0-8212-1131-5.